We are covering network topology architectures for the CCNA exam, focusing on where each design fits and its specific trade-offs. In a large campus environment, the classic model is the three-tier hierarchical architecture, which consists of the access, distribution, and core layers. The access layer is where end devices like PCs and phones connect. The distribution layer aggregates traffic from the access layer and handles routing and policy enforcement between VLANs. The core layer is the high-speed backbone responsible for fast and reliable transport. For smaller to medium-sized businesses, the exam will test your knowledge of the two-tier or collapsed core architecture. This design combines the distribution and core layers into one, which reduces cost and complexity, making it a practical choice when a dedicated core backbone isn't necessary. A common exam trap is to confuse the traditional three-tier design with the modern spine leaf architecture. When you see a question about a data center, your first thought should be spine leaf. This two-layer topology is composed of spine switches that act as the backbone and leaf switches that connect to servers and storage. Every leaf switch connects to every spine switch, which optimizes the east-west or server-to-server traffic common in data centers and provides predictable low latency because any server is a maximum of 2 hops away from any other. For wide area networks, or WANs, the CCNA focuses on 2 key topologies. The hub-and-spoke model is used when multiple branch offices, the spokes, need to connect to a central headquarters, the hub. All communication between spokes must pass through the hub, which simplifies security but creates a single point of failure and potential bottlenecks. In contrast, a full mesh topology provides the highest redundancy by connecting every site directly to every other site. The exam will test you on the trade-off. Full mesh is highly reliable but expensive and complex to manage, while hub and spoke is cheaper but less resilient. Don't overlook the small office, home office, or SOHO topology. Exam questions will portray this as a simple setup, often using a single multifunction device that acts as a router, switch, and wireless access point for a small number of users. Finally, you must differentiate between on-premise and cloud architectures. On-premise means the organization owns and manages all its networking hardware in its own data center, giving it full control but requiring significant capital expense. Cloud networking involves using a provider's infrastructure, which offers scalability and an operational expense model but reduces direct control. The exam will present scenarios where you must choose the best model based on needs like budget, control, and scalability. A simple mnemonic to remember the classic hierarchy is: users get access, policies are distributed, and traffic flies through the core. For free practice questions, AI-powered explanations, and more exam prep tools, visit openexamprep.com. That's openexamprep, all one word, .com.